In this video, we are going to talk about the TrackMate-Napari plugin for doing track analysis using the TrackMate XML and CSV files, and I'm just going to show you what the plugin has so far. Still, the plugin is in development, and I'm going to add more features in it. And let me just navigate and show you the current features which exist in the plugin so far. So this plugin is VollSeg-Napari-TrackMate. You can get it from Napari Hub to try on your own data. What you need to run this plugin are the TrackMate outputs. So TrackMate outputs tracks as XML file. It also gives you tracks, edges, and spots CSV file. And this plugin uses one XML file and these three CSV files to do all the analysis in Python and in Napari. So to get this plugin, so let me first load a file, and I'm going to choose for this particular case a segmentation image. Yeah, so let's say this one. Now I'm gonna convert this to the labels. So that's the label image, and now I'm going to fire up the plugin, the Napari TrackMate. So what you see over here is by default there's no input image because this is now been converted to a labels layer. And these are optional, so that's why I put them as a union of none as an actual label image. So you can actually select this because there is some bit of analysis that you can just do with XMLs and CSV files, right? So you have uploaded the TrackMate XML file, and this is stored in the cache, so you don't have to upload it again. So right now nothing has happened. There's the track CSV, spots and edges CSV, and these are the files which have just been uploaded. There's no plots which have been produced so far. And now what you can do is you have to actually click run. And when you click this run button, it actually takes this XML and CSV files and it creates these internal objects which gives you these kind of outputs like the number of spots over time and all these different histograms which are coming from the TrackMate attributes. So for example, on the top you would see the track start time of all the tracks as a histogram, and on the x-axis are the counts. So for example, maybe what's interesting for you is to see the track displacement, which is something which is stored in these files, but now you can view it as a histogram that on average, as a statistic, what was the displacement of my tracks, taking all of the tracks, and I just want to see the count of the track displacement as a histogram. So you have these plots here, and again this comes with interactive features. So for example, I have already done like a function fits over here. So for this you can choose on these plot options and you can change the axis or the colors and uh, other attributes of the plot itself. And along with these histogram plots which are over in this particular scroll area of the widget, you also have temporal statistics. Like in temporal statistics, this axis is now time. So here we are computing different quantities. For example, at a given time point, I want to know what was the speed of all the cells which were tracked. I want to know the mean, which is in blue, and I want to know the variance. And all of these are the physical units because the physical units are stored in the XML file. So that contains the calibration of the microscope. And then you have some other plots. For example, here you have the radius. So at a given time, what was the size of the cells in the track, the mean and the variance. So you can see over time if the size changed, and you can see also the displacement in different directions. For example, this is the displacement in Z, the mean and the variance, and then I also plot displacement in X and Y for this particular data that you have. So for this analysis, so far you did not even need to have an image open. So you could probably just have done this, chosen none of the images, and you could have just gotten this analysis. But if you want to say, this is just a segmentation image in time and these colors really don't mean anything in terms of the tracks because I haven't colored them with a track attribute. So for example, I would want to say, I want to color all of these cells with the number of times they split in a track, because in some of the tracks there are no splits, some of the tracks the cell divides and then you get one split, and in other tracks the cell may divide twice, so you get two splits. And then if I click run, for which I need this image now because this is now relabeling this segmentation image and creating a new segmentation image where the color of the cells means how many times did that cell divide in its track and how many times did the cell divide, right? So if the cell didn't divide, you won't see it because it's 0. That's the intensity or the value of the label. If the cell divided once, you would see the color brown, which corresponds to 1 in Napari. And if it divides twice, you would see blue. So that means that the cell has divided twice. And now we just wait for it to finish the computation and show up the labels layer on the left hand side. Right, you have to press this run now. So each of these panels, some of them will have their own run button. So this run button was to compute these kind of statistical plots and get this information from XMLs and CSVs. However, you have to press this run if you want to get this segmentation image. So now you have these different colors corresponding to how many times the cell split, right? And this is a labels image. So you can also see this in 3D using this 3D viewer to have a better view of the cells in this way. And let's say, okay, you can choose another track attribute, like I want to color them by their mean speed. So just hit run after selecting the track attribute and wait for the label image to show up on the left side. And now this is the mean speed. So you have to choose the layer and look at the value. So the mean speed of this particular cell was 2564, which I'm reading from the bottom. And for this one, it's 2564 also. So you get this kind of colors now for your cells, where these are the mean speeds. So you can kind of cluster cells based upon the speed. And this is a visual way of kind of representing it. And what else could be interesting is mean directional rate of change. How many times, or what was the directional change of these cells? Did they just go straight, or did they actually turn around or move in an angle, right? So this is giving you this visual output for your tracks. So you uncheck this I so that those two segmentations are not laid on top of each other. And then you get these numbers which are stored in the TrackMate CSV file. So what I do to color this is like, let's say for mean directional change, the value is between 0 and 1. So if you have a value between 0 and 1, I rescale them between 0 and 65,000 something, which is 255 times 255. So now that's why these values appear so high. It's like 30,000, and this is also 30,000 because now I have scaled it between 0 and 655 some 65,000 something, and that's why you see these scaled values. So if it's like this one has half the directional change than these cells, so you kind of have to look at the color, see the value, and then say, okay, so this didn't change much direction as compared to these cells. So this kind of gives you this feedback visually, and these two blocks, they give you kind of statistical feedback histogram wise and time resolve read wise, right? And the plan here is to produce so many of these blocks that you can analyze everything that you could think of. For example, in my previous work, I have analyzed frequencies of the intensities. I have analyzed intensity oscillations of the cells. So the frequency of these intensity oscillations, which could be another panel, which gives you Fourier transform of intensities of cells. You can analyze dividing and non-dividing cells separately, which has not been programmed yet, but that's the idea, that you select one of them, or you select one of these three options, and then you can either analyze just the dividing cells, or you can analyze non-dividing cells, or you can just say, I don't care, just give me a whole picture of my experiment. So then there would be more blocks which contains distance of your cells to the tissue. If you upload optional mask image, this is supposed to be the tissue which is around your cells, and I can calculate the distance from the cell to the tissue boundary. So that will give you if your cell moves with the tissue or not. And then there would be more blocks which I will keep updating you once I make them. But so far, this is what is available, and this is a work which is not funded by CZI, but it is funded by my collaborators who I'm developing this plugin for in Copenhagen. So somebody is paying for the development of the plugin, and I'm happy to hear your suggestions to develop it even more and more, as add as many reads as possible, right? To make you just sit in front of the computer so you can easily analyze what's in my track, what's in my data, how do I do the track analysis, and this um, uh, tabs would contain the different analysis that you can get from this TrackMate universe, let's say. So thank you for your attention and see you.